Okay, today's topic for heat and temperature is topic 7. This is sources of thermal energy. We will be talking about like chemical energy, geothermal energy, kinetic energy, so on. Okay, so we'll start with chemical energy. So examples of this would be things like burning wood for fires. So there's stored chemical energy within that wood, and then it gets released in the form of thermal energy when that wood is burned. Another example would be coal. So again, coal, it contains stored chemical energy, and then when we burn coal, it produces that thermal energy as it burns. All right. So fossil fuels are used for energy. So we'll just take a look at this quick video on fossil fuels. All right, so next is electrical energy. So we get our electrical energy in a variety of ways. So like fossil fuels we already saw in the video can be used to produce electricity. Hydroelectric dams can also be used to produce electrical energy. So hydroelectric dams, these are things like waterfalls. The energy of the falling water gets changed to electrical energy. All right, so gravity, it causes the water to fall downward. That energy of that moving water will turn a turbine, shown here, and then the mechanical energy of the spinning generator within gets changed to electrical energy. All right, but it is that initial energy from that moving water which will turn the turbine, which will then cause that generator to spin, okay, producing electricity. Just looking at here, a dam here. This is, again, it's using water. It's a hydroelectric source. And we're using the energy of falling water to transform it into electrical energy. All right, one thing to note about dams is they do become tourist attractions because they are very impressive to look at. But downside is to nature and the environment and ecosystems. So wildlife, they become affected because the river is no longer flowing naturally. So therefore, plants aren't going to be growing there. Organisms that were eating those plants, they're going to have to move to other areas. And then some people are affected as well because if they used to fish and hunt in that river and in that area, they will also be affected. All right, so it does have these consequences on ecosystems and the land and the water. So we'll watch this video here on hydropower. All right, so electricity can also be produced by burning fossil fuels at generating stations. So these are called thermoelectric or fuel burning generating stations. All right, so burning the fuel like coal will convert chemical energy from the coal into thermal energy. That thermal energy will boil water, and then steam will be produced. That steam will spin the turbines, and then mechanical energy from the spinning turbines will turn the generator, and that generator will convert the mechanical energy into electricity. All right, so heated water, it's a byproduct of thermoelectric plants. And sometimes if that hot water gets released into lakes and rivers, it changes the temperature of the lakes and rivers, and many living things are affected by changing those temperatures of water levels. So there are regulations in place where they do have to cool that water, and then they're able to release it into lakes and rivers. Also, chemicals that are released by burning fossil fuels. So here, when we were burning the coal, it does release gases, which do cause environmental damage, global warming, climate change, and so on. Okay, so next we'll talk about mechanical forces. So these are forces that they're pushing or pulling objects, and they're going to release thermal energy in that process. So for example, if you pound a nail into a piece of wood, the nail will start to feel warmer because thermal energy was released by the impact of the hammer and by the friction of the nail rubbing against the wood. Other examples like car brakes, bike brakes, skidding tires, your shoes, The valve on a bicycle pump, it becomes warmer as air is pumped into the tires, because as air is compressed in the pump, it warms up. Car engines usually have oil to lubricate the parts, right? That makes them easier to slide past each other, so it's easier for those moving parts to move against each other, and therefore reducing friction. It's also going to reduce the amount of thermal energy that gets released because of that friction. So therefore the car engine will suffer less wear and tear. Next, we'll talk about geothermal energy. So geo, like the earth, okay, producing energy. So like think about things like volcanoes, hot springs, and geysers. So inside Earth's crust, there's really extremely hot materials inside Earth's crust. And that hot material that comes out during a volcanic eruption can also produce hot water and steam, which will then move through cracks in the rock. So that boiling water and steam, that can be used. It can be piped to a power plant. It can then be channeled to turbines and then transform it into electrical energy. All right, so that's what geothermal energy is. It's energy generated in the interior of Earth. So HDR, that's hot dry rock. That's a technique for using geothermal energy. So engineers will pump water into rock that has been cracked, and then the heated water will return back to Earth's surface as steam, and then it gets used to generate electricity. So geothermal energy, it is a clean and a good alternative to fossil fuels. Using more geothermal energy can reduce wastes from mining fossil fuels. It'll reduce pollutants from burning fossil fuels. So next we're looking at solar energy. This is the energy from the sun. So some drawbacks to using solar energy are the periods of time when the sun isn't shining. So therefore, solar energy is not available through the night. There's also going to be less solar energy available in winter than in summer. So we'll talk about passive solar energy first. This is when we use materials in the structure to absorb, store, and release solar energy. All right, so for example, in a house, there's a wall of windows on the south side, and other walls are well insulated and they maybe have fewer windows. So the energy from the sun can be absorbed by materials like the concrete in the floor or the water in the storage tank. So that's a very passive way of absorbing solar energy. But during the night, that stored energy can be released and it can warm the air in the house. Okay, so that's passive solar energy. Then we would have active solar energy. This is when we would use mechanical devices like fans to distribute stored thermal energy. So we would have solar collectors, like shown like here, that would be used to collect that solar energy. Okay, so you would put them on the roof or the side of the building that will have the most amount of sunlight. So these solar collectors, they may contain water or air, so shown here. So what happens is the sun beating down, it'll heat the water or the air, and that'll then get pumped through the building. All right, so looking at this diagram, so radiant energy from the sun, it'll pass through the glass, and it'll trap the energy in the solar collector. There's a black metal plate, and just down here, and that will absorb that radiant energy. That solar energy gets converted to thermal energy, which will warm up the metal, and then that thermal energy gets transferred to the water in the pipes, so shown here in the pipes. The water will then flow through the pipes to a basement pump. It will then circulate the water to radiators throughout the system. A fan will be located to help the air that's heated by the water to circulate throughout all the rooms in the house. Cooled water will get pumped back to the collector and get reheated. Also, some active solar heating systems, they may also include large insulated tanks to store heated water for later use. So that's active solar heating. Gonna pause. All right, so next we are looking at wind energy. So this is the energy of moving air. It is still a result of solar energy, all right, because as the sun heats the air, the warmer air rises and then it will cool off. So it's that convection current we talked about. Cooler air will fall, warmer air rises, it creates this convection current, and it's these currents that form the wind systems. All right, so wind systems, or with this wind energy, it can be used to produce electricity. So windmill, it's a turbine, it's a wheel with the fan blades, and then when it spins, it's rotating an electrical generator, which will then produce the electricity. All right, just looking here now at more sources of thermal energy. So burning fuels such as natural gas and oil releases thermal energy in a furnace or car. Our bodies are a source of thermal energy. The food we eat gets digested and then it gets released as energy for growth and activity in our bodies. Some of that energy is also used to maintain our internal body temperature at about 37 degrees Celsius. And then some of that thermal energy from our body also gets transferred to the air and other objects. All right, it gets lost as heat. Examples like huddling together in the cold, litters of warm-blooded organisms like mice, kittens, puppies, they will huddle together for warmth. A composter, so shown in this little diagram here, we have some like worms and so on in a composter. So these decomposers, they break down food. The chemical changes like burning or digesting food, it releases thermal energy, and that thermal energy will also help the decomposition to occur. Fossil fuels, it's an energy resource, so anything that can provide energy in a useful form is an energy resource. Fossil fuels, they are the main energy resource in Alberta and throughout the world. So reminder, what are fossil fuels? These are the chemicals from plants and other organisms that died and then decomposed millions of years ago, and then they have been preserved deep underground. So oceans and silt, that'll exert that pressure on the cells of dead organisms. And then we have natural gas and petroleum oils, which are fossil fuels. So coal, oil, and natural gas. Okay, some problems, or two problems that we'll talk about with fossil fuels. They are a non-renewable resource. Okay, they take millions of years to form. So we won't have them forever. They are non-renewable resources. And we've already used up about half of the known easy to obtain fossil fuels. And then compare that to renewable resources that we just looked at, like solar and wind and so on. These are energy resources that can be recycled or replaced by natural processes in less than 100 years. So trees and food crops would be considered renewable resources because they can usually grow at about the same rate as they are used up. Another problem with fossil fuels is when we burn fossil fuels, we are releasing carbon dioxide gases into the atmosphere. That carbon dioxide gas, it is required by plants for photosynthesis, and it does occur naturally in the atmosphere. But because of all the increased use of fossil fuels and burning of fossil fuels, like just like planes, trucks, automobiles, factories, and so on, it's releasing more carbon dioxide into the atmosphere. Okay, and then that heat from the sun, from solar energy, it's getting trapped by those greenhouse gases, such as the carbon dioxide and methane, and then it's unable to escape from Earth. All right, so it's heating up the Earth. All right, so just in this diagram here, furnaces in buildings and houses are using fossil fuels. Airplanes, trucks, automobiles are burning fossil fuels. Thermoelectric generating stations, they're also using or burning fossil fuels to produce electricity. So global warming. So normal amounts of carbon dioxide in the atmosphere is important because it keeps our Earth warm enough to support life. But it's the increased amount of carbon dioxide and other greenhouse gases like methane that are being trapped, or they're trapping thermal energy. They're warming up the Earth at a rapid rate. Okay, and that rise in just a few degrees in our temperature can make a big difference. It can change climatic zones and their plant growing abilities. It can dry up rivers and lakes, and it's also melting the polar ice caps. All right, so we'll talk a little bit more about climate change and the effects of climate change. We'll watch a couple of these videos. Cogeneration we're going to talk about next. So thermal pollution, this is when there's a warming of the environment. It's resulting from human activity such as the burning of fossil fuels. And then cogeneration would be a method that uses the waste heat to generate electricity or heat buildings or other useful tasks. All right, so here in this image, there's this power station in Denmark. It burns straw as fuel, and then the plant heats adjacent greenhouses as well from that waste heat. All right, so we'll just watch a couple more videos here.